Hello, everyone. Mr. Minix, my name. Math is my game. This is the first in a four-part series. It's called TI Topics, and what we're looking at right now in this particular TI Topics lesson, these are intended to be about 20 minutes in length, to get you up and running with a TI-Nspire graphing calculator and the tools. And I have a handout for my class that they're going to be using, and these same tools will be on that handout. The tools that we're going to use, let's think back to when we first studied lines. There's one form that everybody knows. Y equals mx plus b. Good. Everybody knows it. Of course, we know that m is the slope and b is the y-intercept. There's this other form. I joke around when I say this, and it's really no joke. You don't want this. Not that I know from experience, but you don't want this other form that you don't want the abbreviation to. This form. That's standard form of an equation of a line. Okay. Sometimes equations are given in that form. It'd be nice if we could modify that a little bit. Maybe we should do that now. What if we took that and we got by all by itself? That would equal negative ax plus c, right? So solving that in terms of y, then y equals negative a over b, x plus c over b. So the helpful thing about that is if you wanted to find slope, and something's in standard form, you can use that and that to find the slope and the y-intercept. Okay, pretty handy information. Two more tools that we'll use here. One of them is going to be the formulae for slope, and I think everybody knows that. The slope formula says that to calculate slope, it's a fraction. What do we have in the numerator? Y subscript 2, take away y subscript 1, divided by x subscript 2, take away x subscript 1. Right? And there's one more tool that I'm going to give a shout out to Mrs. Morgan. I heard her say this. I heard her use this. She said she just used Vuxhoy. I'm like, what the heck is Vuxhoy? Vuxhoy's great. It's awesome. It's a great way to memorize that vertical lines have an undefined slope and their equation has x equals a number in them. And horizontal lines have a slope of 0 and their equation is y equals a number. Okay. So how are we going to use the TI-Nspire to do anything about lines? Well, I don't know. Vertical lines have an undefined slope? Yeah, vertical lines have an undefined slope. Well, I wonder if the calculator would help us on some of these. Maybe it's not going to. Maybe it's not going to. Example 1, let's find the slope and the y-intercept for each one. Slope and y-intercept for each one. Something like this, something like 3x minus 4y equals, I need a nice number. How about 24? Could we maybe use the TI-Nspire to help us some way on this? Okay. Maybe we should try, first of all, on the Nspire, just a quick word of wisdom, a bit of advice. I see a lot of people using the scratch pad. It's not bad too. But the scratch pad is limited. It doesn't do everything else that the calculator can do. So I'm not saying it's horrible to use, but I'm saying that there's more features available in the rest of the calculator. So I'm actually going to go ahead and use a graph page, not the scratch pad. So I need to try to graph this 3x minus 4y equals 24. 3x minus 4y equals 24. Now, if I go to the calculator, it's asking me f1 of x equals, right? If I delete all that, if I back up one space, it'll give me the option to graph an inequality, okay? But it won't let me put an equation in standard form, or will it? What happens if we press the menu button? Actions. Pointer's not going to help. Select. Nope. Hide show. Nope. Menu. Actions, I don't think anything there is going to help. Wait a minute. Coordinates and equations, redefine text, delete all, set conditions, attributes. Maybe that's not going to help. Maybe view. Plane geometry, 3D graphing, height axes, grid, show entry line. What about graph? Oh! What happens if we do something up here with function? Okay, no, that didn't help. Menu, graph, entry, edit. An equation? A line? Oh, it lets us do this! Yeah! If you're at home having a heart attack, I'm sorry. But look, we got there. Look at that. That is amazing. That is amazing. We went menu. We went option 3. And then we went to equation. And we went to line. And it gives us the option to graph a standard form line. Yes! I just broke your speakers at home. I'm sorry. And your eardrums. I'm sorry about that too. So what do we have? Well, I hope somebody wrote it down. 3x. And now it's minus 4y, so we'll have to write plus minus 4y, right? And then, was it 24? That's just so cool that we could do that, though. That's cheating. Oh, I wonder if we could find a slope. I wonder if we could use our special eyes. I got to be careful when I say this. I say we use our anal eyes. I know this isn't calculus, but if you actually find the dy dx, that's a slope. And the slope is, did it show and I just didn't see it? Menu, analyze, dy dx, and the slope is 0.75. It asks us, what about the position? Where do you want that? Well, it doesn't really matter where you go. Wherever you go, the point's going to be the same. So the slope's 0.75. So the slope according to the TI-Nspire, it's the dy/dx. That's actually a calculus concept. It's the derivative, the first derivative. But the slope is 0.75. Now your math teacher is going to hate 0.75. Is going to say, you cheated. What's your math teacher going to want you to write it as? Thank you, 3/4. Okay, so the slope's 3/4, and the y-intercept. To get the y-intercept, could we find that on the calculator? It looks like it's -6, but to be sure, couldn't we just go to a table? The calculator will auto default to a window of 10 to 10 on the X and 6.67 to 6.67 because that's its default window. That's its standard window. I don't know why they don't make the default 10-10. Okay, but what if I go to a table? Will that give me the y-intercept? Or I could, well, yeah. So Control T. There are no functions. It's not going to let me do a table. It's not going to let me do a table. So maybe I want to use my analyze again. Maybe I want to not use my analyze. Maybe I want a point on the graph. I want to go graph trace. And this is going to be tough on a handheld. On a handheld, this might be a little bit tougher, but watch this. That's a good question. I went menu, trace. Let me try menu. Let me try a point on. What if I go to graph? There's got to be a way to put a point on this. Analyze the graph. Nope. Trace. Another line and see where they intersect. A straight, like a vertical line when x equals 0. I like that idea. That's awesome. So let's see if we can put a vertical line when x equals 0, and then we'll find the intersection. That's a great idea. Great idea. So we're going to go tab to enter a second equation. Menu 3, equation, line, vertical line when x equals 0. And now we're going to use our special eyes. But maybe we need to get this viewing window a little better. Menu, window, let's zoom out from here. And now we'll use our analyze. and we'll find the intersection. And so our y-intercept, oh, menu, analyze, intersection, first corner, okay, here, second corner here, no intersection found within the specified bounds. I have to hit it on the line? From left to right? I don't know. Let's see. Menu, analyze, intersection. Over here, over here. It's not doing it. Ah. Ah. If anybody finds a way, it's probably easier just to plug in 0 for x and solve for y, yeah. So, but I'm impressed that we could graph a standard form equation, huh? That's pretty sweet. Okay, cool. So we saw that we could graph a standard form equation. That's terrific. We saw that we could graph a vertical line. That's even better. Does it equal negative? It is -6, yeah. Yeah, so back to the y-intercept on this. I use a technique called the cover-up technique. It's really not called that, but that's what I call it. What I'm going to do is I'm going to cover up that term, the 3x, because the y-intercept is the value of y when x equals 0, so that term goes away. So the y-intercept, we get -4y is 24, and we divide and we get y equals -6, okay? Or 0, -6. Okay, question. We got away. Awesome, let's hear it. Do the intersection again, so menu. So we want the intersection. So up here and then down here. Oh, there it is. Awesome. I was just clicking in the wrong places. Sweet. Awesome. Thank you. Good looking out. I'm glad we're doing this. Menu, analyze, and we just got to click in some areas across where it actually meets. Good. Sweet. Nice. Good find. So I think really to handle all the stuff we need to handle, there's really only one more thing. One thing to caution you on, and then one more thing to look at, and that's how to set up a good window. Okay, so example 2, let's try to graph y equals -2/3 x plus 5. If you had to punch in something like that, just be careful where you place the x. Okay, word of caution, be careful where you place the x. Be careful where you place the x. If x is in the denominator, we end up with something that's not a function. So I'm going to go ahead and insert a new problem, and I'm going to insert a graph. And it's negative, what was it, -2/3? So 2/3. And this calculator is intuitive enough. If I punch it in wrong, it's going to make it right for me. If I actually punch it in wrong, what was it, +5 then? I punched that in wrong, but it actually makes it the right way for me. It's very intuitive, almost too intuitive. Notice the way it wrote the function. If I had accidentally, inadvertently put the x in the denominator, let me see if I can get to that command line and do that. If I inadvertently put the x in the denominator here, like that, watch what happens. Remember graphing those in chapter 8? That's not cool. Okay, so the deal is just be careful with where you put the x. Okay, just be careful with where you put the x. And I keep clicking in the wrong places. Okay, I keep clicking in the wrong places. It reminds me of Texas. All my exes live in Texas. Okay. So we found out how to find the slope. How do we find the slope again? Using the graph, can't we use the derivative? So the slope here is -0.6666666666, or -2/3. We should have known that, right? Okay. There's only one more thing we need to see, and that's how to find a good window, and that's it. Okay? So what if we wanted to graph something like this? Let's try to graph y equals 7,000 x minus 500. This is the kind of thing that comes up in a business model. You get $7,000 for every unit sold, or 7 $1,000 million for every unit sold, but it's going to cost you $500 million to make one, or right from the beginning to get started. Okay, this is the kind of thing that shows up in businesses all the time. So if we graph this, we're probably not going to see much on our 10 to 10 window, are we? If we go, actually it's not 10 to 10. What's it go to? Negative 10 to 10 and 6.67 to negative 6.67. We're not going to see a blasted thing because the graph's going to be, well, first of all, it's going to have a very steep slope. It's going to have a slope so steep that it's going to seem like a vertical line, and the line's going to be so far down here that we're not going to see anything. We're not going to see anything, are we? So how do we set up a good window? I'm going to insert a new problem. I'm going to make this a graph page. Before I even graph this, I want to go to the window. What would make sense for an X-min? Could we leave it at negative 10? Negative 700 for an X-min? We could probably leave X-min alone, right? And we could probably leave X-max alone. But the Y needs to change. If we plugged in 1, it'd be a couple thousand. If we plugged in 0, it's negative 500. But if we're going to negative 10, we want to leave well below that. Where should we start? Negative 7,000 is not going to show us much. That's only going to show us one thing to the left. Negative 600? I don't think it's going to be enough. What about the Y max? 14,000, I'm hearing? What kind of scale? Maybe we should leave that as automatic. Let's see what happens. Okay, so we'll see what happens. So we had what? 7,000 x minus 500? Well, we see part of it, but maybe we want to see a little bit more of it. So we go back to the window, and negative 14,000 on the Y min. Okay. I said negative 14,000. And okay. And okay. That's a little better. But we can't see what happens when X is 3 or 4 or 5 or 6. A million to negative a million? So negative 1. There's a way to get times 10 to the, it's an EE. I don't see it. Here it is. Negative 1 million. Whoop. Wrong one. Thank you. So negative 1 million to positive 1 million. Let's try that. Now we don't. Now that's not so good. Maybe we should let the calculator pick a good window. Let's see what it'll do. Let's go to zoom. Standard takes us back to square one. It looks like a vertical line. Menu, zoom, fit. There you go. There is a reason for those things. There is a reason for those things. Any questions, comments, concerns? It's been real. It's been fun. I hope it's been informative and educational. I'd like to give a shout out to Derek Miller for coming up with how to get that intersection point. And I'd also like to give a shout out to the future Mr. Minnick and any YouTubers watching at home. See you next time.
Good.